Section 5.1, we're going to take a deep dive into polynomials. Polynomials comes from the Greek poly, meaning multiple. These are multi-parted numbers. And so they have a lot of parts, and these can be visually overwhelming at times. So don't freak out when you see a polynomial, which is a single number represented by a whole string of terms. It happens, and we're going to learn how to engage them. So this is the textbook definition where A, B, C, and D, and so on are just coefficients, just numbers, real numbers. And n minus 1, and minus 2 are the exponents on those. So that is what the textbook gives you, but an example which may make this feel a bit better for you might be something like 2x to the 5th power minus 3x to the 4th power plus 17x cubed, plus 2x squared minus x plus 1. So you see the n minus 1, n minus 2, n minus 3, that is the 5, 4, 3, 2, and then understood 1 right there. That is the exponents getting smaller. And you see you have just a bunch of numbers, coefficients, numbers being multiplied by those x's. So that is what a polynomial looks like. That is an example of a polynomial. And they range in size from just little quadratics and even linear functions all the way up to big behemoth things like this. So important information to know. One, polynomials have a lot of nice features to them. They're relatively clean. And by that I mean things like domain. Any polynomial is going to have a domain that is negative infinity all the way to positive infinity. There's nothing you can plug in here that's going to cause problems. This is not a rational thing. It's not a fraction thing where the denominator could be 0. It's not a square root. We have to worry about square root of negative numbers. There's nothing nasty about this. The domain is always nice and neat. Now the range is not as nice and neat. Sometimes the range is all real numbers like the domain is, and sometimes it's not. There are limitations to it depending on things like degree, as in what is the highest exponent used. That can determine the range. So the range I'm going to leave open in this moment because the answer is it can vary depending on leading coefficient and the degree, the exponent used. So we'll talk more about that in subsequent videos. But we have domain, we have range, and let me see if there's anything else I want to include on this. It's a nice, neat function that you will learn a lot about in upcoming videos.